Hello, my name is David Bompard, and on today's video KV, we're going to be talking about the Log4j configuration for Spark streaming applications. On today's agenda, we have a brief introduction on Log4j for Spark streaming application, proposed configuration, how to submit the application, and what kind of information we can find in the user interface after applying this change. Spark streaming applications are continuously generating logs. So the Spark streaming applications usually run for very long periods of time before facing issues that may cause them to be shut down. In other cases, the application will not be even shut down, but it could be facing performance degradation during peak hours. In any case, the amount and size of these logs will keep growing over time, making it really difficult to analyze when they start growing past the gigabyte size. Spark uses Log4j as a logging facility that we can leverage and make it work according to our needs. So it's well known that Spark, as many other applications, uses Log4j to handle logs for both the driver and the executors. Hence, it is recommended to tune the Log4j properties files to leverage the rolling file appender option, which will basically create a log file, rotate it when a size limit is met, and keep a number of backup logs as historical information that we can later on use for analysis. About the Log4j scope, updating the Log4j properties file in Spark configuration directory is not recommended, as it will have a cluster-wide effect. Instead, we can use it as a template to create our own Log4j file that is going to be used for our stream application without affecting other jobs. As an example, we will create a Log4j properties file from scratch. We will be creating one for the driver and another one for the executors. Both of them will kind of share the basic configuration, and we will be making two because we want to differentiate the driver log file name versus the executors. So each log file will have a maximum size of 100 megabyte, and that is specified using the max file size, as you can see on this slide. 100 megabyte size is a reasonable size that can be reviewed on most file editors while holding a reasonable time lapse of Spark events. Next, we will use the max backup index equals 10 because we want to preserve the current log file and also the previous 10 attempts. I mean, the previous 10 logs that has been generated before. The files will be saved in a custom path. That's why we have park yarn app container logdir variable in here. So this variable defaults to the node manager's logdir, and VM login name -driver.log file, it's going to be created inside the container. So each container, as we already know, runs inside its own virtual machine. So on its own directory in the local file system, we will have a single file for each of them. Next, we have the VM login level. This property is going to be very useful because we will not have to go back to the log4j driver properties file or the executors one and update this every time that we want to execute a new Spark application. So what we're going to be doing is that we're going to alter the value of this VM login level on the Spark submit job. And we're going to see that in a moment. So again, the VM login name will allow us to have different driver log files per application by using a different application name for each Spark streaming application. And the VM login level will allow us to set a different log level for each application without altering the content of the log4j properties file. This is a very simple and straightforward template on how we can tell Spark that it should be using a log4j-driver properties file with a log level debug and a VM log name Spark streaming-1. These three properties and values will be passed over to the driver extra Java options, and we're going to do the same for the executors, as we can see on line 4 and 5. This is something more close to a real life example. Actually, this is the Kafka word count example. As you can see here, we're submitting a Spark job on Yarn using the deploy mode as cluster with 3 executors. Then we are specifying the key.conf file, which is the JAS file that we have to provide to Spark so it can be able to communicate with Kafka. This is supposed to be a Kerberized cluster. Then we pass the log4j drivers driver properties file along with the VM login level and the VM login naming as we saw before. We do the same with the executor, and then we pass the rest of the arguments. So the file that's equal files would have the key.conf, which is the JAS file, the key tab that we have to pass over, the log4j driver properties file, and the executors also. After that, we have the repositories and the packages and everything else that we need to specify if we want the Kafka word count to be able to execute successfully. When the application has been submitted and Yarn accepts it, we will be able to find in the Resource Manager UI one attempt. Okay, so if we click on that attempt, it will take us to the following screen where we can check the logs for each of the executors and the driver. So let's assume that the first one, the container which ends in 01, it's going to be the driver container, and 02, 03, and 04 are going to be the executors. If we click on the logs link, which is on the right side, it will take us to the following screen where we can see a new file name for the driver, and we have the same for the executor. So initially we will have only one single file because the streaming application has not yet reached the 100 megabyte size. So it will not roll over to a new file yet. After a while, let's say after a couple of days or at least 24 hours, we will be able to find the following. So as you can see here, we have a Spark streaming -1 -driver.log.1, 2, 3, 4, 5, and all the way up to 10. This comes from the max backup index, which we have set as equal 10 in the driver log4j properties file. Additionally, we have the current log file, which is the first one, the first line. And as soon as that one reaches the 100 megabyte size, the older file is going to be rotated, and the current one will become the most recent .x file. The same way, if we go to any of the node manager nodes where we have confirmed that one of the executors is running on, we can check the node manager's log there, find the application ID followed by the container ID, and inside that directory we will be able to find in local file system the Spark streaming -1 -executor.log. This is going to help us a lot because when we require to collect only the executor logs, for instance, or only the driver logs, we can use the find operating system command and specify the application ID, and it will only retrieve us what we're looking for instead of everything altogether. Thank you for joining this video session, KB. Hope it has been of great help for you.